Welcome back, A&P students. We are about to talk about the urinary system here. Let's go ahead and get started. Why not? So we see our two kidneys here. Boom, boom. There they are, sitting in that posterior abdominal cavity. Right kidney pushed down a little bit by the liver. Left kidney a little bit higher, adjacent to the spleen, the stomach, and the colon. Kidneys always making urine, constantly making urine. Urine draining via the ureters. Ureters doing some smooth muscle peristalsis, taking that urine down to the urinary bladder. See her urinary bladder here? Her, because, well, there's a uterus right there. And the urinary bladder holding on to the uterus in order, holding on to the uterus, holding on to the urine, waiting for it to be convenient to be released via the urethra. Okie dokie. So why do we make urine anyway? Well, big reasons. We gotta get rid of the bad stuff in blood. We gotta filter, remove the waste from our plasma. First step in making urine is filtering the blood. And in making urine, obviously urine is a fluid. So as a fluid, it's derived from blood. I mean, the more water you put in your urine, the more water is leaving your body, the less blood volume is going to be. And as blood volume goes lower, well, so does blood pressure. All right, well, what else do you regulate about blood? Well, we're regulating blood's osmolarity. In other words, how many particles does it have? How concentrated is it? If it's too concentrated, blood steals water from your cells and tissues. They shrink. If blood is too dilute, too much water goes into your cells and tissues. They swell. Neither of those situations are good. All right, secondary functions. Well, we make renin. We make renin. Okay, renin is that chemical that was involved in a complex pathway that raised blood pressure. Kidneys also make EPO. And I know you know that EPO stands for erythropoietin. Erythropoietin is going to stimulate erythropoiesis, the production of red blood cells. Urine also regulates the pH of your body. The more acid you pee away, the less acid is in your body. Think about it that way. What else? The kidneys help you make the active form of vitamin D, which is this hormone called calcitriol, which is going to help your calcium balance. Kidneys also can make new glucose out of amino acids or fatty acids. And that process of new glucose production, let me check out the word here, new glucose production, is gluconeogenesis. All right, cool. Quick digression here. Since we're talking about the kidneys, we got to talk about their immediate neighbors, the adrenal glands. Ad next to renal, obviously, kidneys. Adrenal glands sitting on top of the kidneys. They're also known as the suprarenal gland because of that. Excuse me. And their hormone factories, their cortex is making aldosterone, cortisol, lots of other hormones. We met we'll meet aldosterone a little later this system. Cortisol is your stress hormone, and cortisol is hopefully what you're not releasing as you're studying for your A&P test, because cortisol dampens your immune response and makes you store abdominal fat. Not good things. The medulla of the adrenal gland makes epi, norepi, your fight or flight hormones. Okay, there's our quick digression. Now it is time to go over kidney anatomy. Look at that frontally sectioned kidney. We see this nice capsule on the outside. Fibrous capsule, collagenous capsule, helps anchor and protect the kidney. Just deep to that, we've got our outer region of the kidney, the cortex. This is where urine is going to be made. Urine constantly made in the renal cortex. The urine drips down these ducts that are in these renal pyramids. This is a renal pyramid right here. And on this view, I can see 6 renal pyramids. There can be more than that. Collectively, the renal pyramids make up the renal medulla, and urine is constantly dripping through the renal pyramids. Okay? The tip of each pyramid's tip is called a renal papilla. So this is the third place we've seen papillae in the body. this semester. And the renal papillae project into these little cups. This is a little cup, little tube called a minor calyx. I say cup because the word calyx means fancy cup, not unlike the word chalice, from which it's and chalice comes from the word calyx. I know you guys love etymology, of course. When two minor calyces come together, boom, boom, we get a major calyx. When all the major and minor calyces unite, we get the renal pelvis, which narrows and leaves as the ureter. And the narrowing happens in this indentation in the kidney here, which is the renal hilum. And all the space that's in the kidney occupied by blood vessels, by these tubes, by fat, is the renal sinus. What else do we see here? Well, we do see some cortical tissue out here, cortex out here. And here's the pyramid. Notice the different color. And notice how it's like the cortex kind of extends down in between the pyramids. And this extension downward here is called a renal column. So in between every pair of pyramids, we'll find a column. Collectively, a single pyramid plus its column and cortex around it is known as a lobe of the kidney. A lobe of the kidney. And, of course, got the artery and the vein. Artery bringing blood in, vein taking blood out. Of course, the artery is going to be dirtier than the vein in this case. This is a rare organ where the artery is dirtier than the vein. Think about why that is. Let me know if you're stumped. And also, let me know if you can't figure out any of this stuff. You should be able to do this basic pathway of urine flow. Okay, speaking of basic pathways, now we got to do the basic pathway of blood flow. So we got our renal artery. Renal artery splits to give us several segmental arteries going to different big chunks of the kidney, different segments. Segmental arteries divide to give us several interlobar arteries going up between the pyramids and thus between the lobes. The interlobar arteries branch to give you some curvy guys going over the bases of the pyramids. Because these guys are curvy, each is called an arcuate artery because they're arch-like, arcuate, arch-like. And then branching from the arcuate arteries are all these guys. There's more of them than the picture gives credit for. These are interlobular arteries spreading out throughout the cortex. Those are all the gross arteries, the ones we can see with our naked eyes. We can see our gross veins here too. Interlobular veins here in the cortex, emptying into these arcuate veins that are arching over the bases of the pyramids. Arcuate veins fusing to give rise to the interlobar veins. Interlobar veins are going to come back, and this is where it gets just a wee bit weird here. The interlobar veins join together, and we get interlobar veins still. We don't call them segmental veins, even though they're segmental arteries, and you'd think this should be a segmental vein. It's not. It's just a little bit weird. So the interlobar veins ultimately fuse together, get bigger and bigger, and become the renal vein. Awesome. Now, we can also see, if we zoom in the cortex, the microvasculature. Here's the arcuate artery. Here's the interlobular. And coming off the interlobular arteries, we're going to have afferent arterioles going to a ball of capillaries called the glomerulus. And by the way, there's about 1 million of each of these in each kidney. The glomerulus is where the filtration of blood takes place. That's the first step in making urine. We filter blood. The fluid that's formed called the filtrate ends up in this little tube called a renal tubule, where we modify the filtrate. And eventually the filtrate ends up in this big tube called a collecting duct, which is going to contain urine. Now, leaving the glomerulus is an efferent arteriole. It gives rise to either a set of capillaries known as a peritubular capillaries or a set known as the vasa recta, where further modification happens to the fluid that's going to become urine, and we end up making urine. And eventually, the blood gets back into the interlobular vein, and I'll see you later.